Welcome to Hacktics and Telemetry, Episode 5. I am one of your co-hosts, Douglas McKee, or Full Metal Packets, and of course, I'm joined with the one and only Crypto Cat. And if you have not seen any of our previous episodes, please go to our YouTube page and check out episodes 1 through 4. If you get a chance, we'd love for you to like and subscribe. Put stuff in the comments. Tell us what you like. Tell us what you don't like. Tell us what topics you want us to cover next time. One topic that we keep getting a lot of heat for covering is AI. I think maybe, hey, Jonah, maybe we should add a counter for how many times we say AI, even though I keep trying to stop saying AI when we're talking about stuff today.
It might go off the screen.
It might go off the screen. Are we talking about AI today?
Maybe. I mean, did you hear about the startup getting wiped out by Cursor?
Hold on, you're telling me that something went wrong because someone was using AI? Is that what you're telling me?
Yeah, apparently there was a startup called Pocket OS, which basically had Cursor running with like God mode permissions, and yeah, it wiped out the entire database, backups, everything. And a great example of why you can't just like trust using your prompt for everything. You can't just like say, don't touch this.
If I'm remembering correctly, you can correct me if I'm wrong, but I believe it took all of 9 seconds for Opus 4.6 to do that. So maybe that's why we have Opus 4.7 now. Maybe it's smarter. Maybe it won't delete as many things.
Maybe it'll do it in 3 seconds.
Check your permissions, people. Don't run in God mode. That's not the right thing to do. Anyway, I digress. We will be doing our normal 3 segments today. We will be starting with the Situation Room, where Jonah will tell us what's going on in the world, and we'll have a discussion about the latest and greatest news and research in cybersecurity. Then we will jump over to the War Room, and we've got a real treat for you today. We've got a special guest who is going to walk through his research, Jorian, talking about a Roundcube cross-site scripting chain, and he's going to do a live demo. Stay tuned. We'll see if it works or not. I hope it does. And then last but not least, we have another guest joining us for the Mitigation Minute. If you're not familiar with the podcast, that's where we like to talk about not what's just going wrong, but what you can do to help with what's going wrong in the industry. And we will have the one and only Spencer joining us again to show us how Metasploit can do a few cool new things, including, if I'm not mistaken, using an MCP server. So there we go. There the AI counter is just going up and up and up, and we haven't even started yet. Jonah, are you ready to jump into the Situation Room?
Yep, let's do it.
All right, here we go. Here we are in the Situation Room. All right, Jonah, he's going to walk us through some of the latest and greatest stories. What happened since the last time we recorded a podcast?
Yeah, all right. So the first thing here was, we know obviously there's been a lot of talk about the new Mythos model coming out, and that was given like early access, right, for companies and defenders to basically go and start securing their code. Well, we also talked about Expo. Whenever they got the new ChatGPT model, they basically said that they were getting as good, if not better, results with that than they were with, I think they were testing the Mythos model, but maybe it was actually the latest Opus model, but they were getting very good results anyway. And particularly with like combining the model with like a more of a black box approach rather than just doing source code analysis, which is what the models are currently kind of famous for. That's what most people are using them for, with like full research, bug bounty, things like that. This is an interesting one because the GPT 5.5 cyber is going to come out. It's basically the same situation where they're going to release it for some defenders, some like corporations, and like I think critical infrastructure and things like that to basically go and secure their systems first.
So they're not going public with it right away. I'm not going to get it on my ChatGPT subscription tomorrow.
They're not, and that's kind of interesting because I don't know if you remember, Doug, but at the time, whenever Anthropic came out and said like, we're holding this back, we need to like give early access to these companies, I think there was a bit of like pushback from OpenAI, like why are you doing that? Or that was kind of the talk at the time, and yet they seem to be coming out with a similar approach now. It's like, oh, actually, our model's a bit too dangerous as well to release to the public. We need to give early access. And actually, I was playing around with Codex over the weekend, and for the first time, I noticed whenever I was doing some like bug bounty, full research stuff, and whenever I gave a prompt, it basically came up with a warning saying like, you're not allowed to do that. You know, like this is dangerous hacking stuff. But for the first time, it came up with a link saying you can come and apply here to basically like to get access to do this stuff. And I thought that was going to be similar to like Anthropic, where you go and you like explain, I'm a security researcher, like here's my CV, here's my LinkedIn, you can trust me. But it wasn't. It was just like, give us your ID, like upload your passport, your driving license, and then you have access to do bug bounty and do vuln research, which I thought was interesting. It's quite different to Anthropic's approach.
It's wild, right? And then there were 2. Like this is just the continued trajectory of the evolution of the technology, and you know, honestly, it's what I would expect.
Absolutely. And so what I want to talk about with this one is some of the results they had. So there's a chart here where they basically compare each of the different models. And this is just doing like some CTF challenges, I believe, so like practitioner and expert. They test all of the different models. And where do we have? GPT 5.5 is here for the expert and then up here for the practitioner. What I thought was interesting is Opus 4.6 is here. So 5, GPT is, okay, 5, then 7 is Mythos. Okay, so it's going up quite a bit there for Mythos. But then 10, you have GPT 5.5 above that. So it actually seems to be performing better based on these benchmarks than the Mythos preview is doing.
Well, I love, here's a hot, or not a hot take, here's a question for you, because I know that you're heavily involved in CTFs or have been heavily involved in CTFs in the past, playing a lot of them, and you've even organized some, right, I believe, from a CTF perspective. When I take a look at this, I think CTFs are a great learning experience for humans. I have to be explicit these days, in order to get skills and to get better. But one of the things I say about a lot of CTFs is they're actually not one-to-one to real life experiences. In fact, there's many CTFs out there that I think are very contrived, right? So when I look at results like this, I think it's amazing that these AI models are able to complete CTFs, but I don't directly correlate that to the skills needed to do the same thing in a reliable fashion that we do as vulnerability researchers. So curious, this question to you, like, how do you take that kind of data? Do you, what does it mean to you?
Well, I think as well, at the moment, a lot of this is all just kind of in training, right? You have like Hack the Box, HackerOne. I know they've been quite involved with AI stuff because I played a CTF before. It was with GraceOne, and it was like all three, HackerOne, Hack the Box, GraceOne, all kind of combined to make the CTF. And compared to like a normal Hack the Box CTF would be you like running Nmap and like you're opening the browser, you're going to like check the source code, try and XSS, things like that. This was a different CTF. It was the same in that you have like these boxes that you need to attack, but the only way you can talk to those boxes is through the AI agent. So you basically had to do everything. If you wanted to run Nmap, if you wanted to run like GoBuster, if you wanted to do like SQL injection, stuff like that, you had to basically ask the agent, like, run this tool and do this, and like it will come back with the information. So it was really cool because like you were getting to see like how powerful that could be. But at the same time, I was kind of thinking like every CTF is basically just training for that model. Do you know what I mean? To the point where, is this going to be like they don't need us anymore, and we've basically CTF'd ourselves into or out of employment?
It would be interesting to hypothesize about the future of some of those CTF learning-based companies. Like, how do they have to evolve when it comes to these technologies and as they become readily available? That's an interesting thought or interesting conversation.
Absolutely. Just one other thing for this that I wanted to mention then, Doug, was this one here, the last ones. It's a 32-step corporate network attack simulation built with Spectre Ops. It's modeled on a kill chain of enterprise intrusion. Spans 4 subnets, roughly 20 hosts. They've basically created this big network for the AI to test out and see how far it can get. And then this is the chart that they have of how it's doing. I think did they say that none of them have fully solved it? We estimate it would take a human expert 20 hours to complete the full chain. And GPT 5.5 did it end-to-end in 2 out of 10 attempts. And Mythos Preview did so in 3 out of 10 attempts. So here is the last ones per spent tokens and how they perform. So there's the best attempts, and I guess here's the average attempts as well.
Definitely impressive stuff, for sure. It'll be interesting to see how it shapes or continues to grow, and whether the test environments are indicative of what actually is needed to do things in real environments. Because there's as I said, there's so many differences between real environments and test environments. I'll be interesting to watch how this unfolds for sure. But another area that this applies, and I think there was another story this week, Jonah, to talk about related to this, was so CTFs are also somewhat similar in a sense to bug bounties, right? So like what are we seeing from an evolution perspective as these new models come out as it pertains to bug bounties? And shout out to our previous guest, right? We had Harrison on here talking about how he's evolving bug bounties. He's done bug bounties most of his career and his bug bounty framework. If you did not check out that episode, go back and check it out. Awesome to have Harrison on walking through his methodology. And he even announced how he had an MCP server in his new bug bounty framework. So with that context, there what I know there's been some latest news from Google around these bug bounty programs. What did we see from Google this go around?
Yeah, let me just open that up. So yeah, this has been a big topic of discussion as well, and there's been a lot of talk on Twitter about this recently. Google VRP.
Ooh, I saw some big numbers. As you scroll back and forth,
Yeah,
I saw some big numbers.
Big numbers. So this is interesting because they've actually increased some of the bounties. This, I think, went up from 1 million to 1.5 million for a 0-click on like the latest
just to be clear,
mobile.
In the age of AI helping us with vulnerability research, Google's actually paying more for certain bug bounties than they were before. Is that what you're telling me?
For certain bug bounties, yeah. What they basically say here is that they have recognized, how AI is advancing things and they're shifting the structure. I think one of the things was the memory safety bugs. So if I'm not mistaken, they reduced them to start as low as like $500 and also removed some bonuses. They had bonuses previously for RCE, I think just for Chrome, like RCE and arbitrary read and write. And they basically added these bonuses because they weren't getting enough RCE reports. And then now it's got to the point where they're getting too many RCE reports. They're too easy to verify and fix. And yeah, they're basically changing the incentive structure. So they're removing these bonuses to the renderer, RCE and renderer arbitrary read and write bonuses. They are incentivizing actionable reports. They are also looking for reports.
The way I read that is incentivizing actionable reports means we don't want AI slop. Like you have to be able to provide us something that's actually useful, not just automatic generated. And I think that's a subtle nod to the recognition in the industry that, yeah, sure, AI is helping us, but it's also creating in some instances more chaos than it is help. And they're like, hey, we want good stuff, not just decide to stand up Claude and shoot it at something.
I mean, they're specifically saying here, like, they don't want lengthy, detailed write-ups, which is completely opposite. We've heard from Bug Bounty, over the years. It's like, you need to like put as much detail as possible, make sure you have all the steps, screenshots everywhere. It's like, now they're actually like, look, just give us the POC. Just give us the steps that show exactly how to do it.
But that also speaks to, I think, and I could be wrong, by the way, this is Doug's opinion. I don't know anything about what Google's actually doing here, but I suspect that they're then leveraging AI on the back end to process those reports and to validate those findings so they don't need as much detail as they used to need to leverage them because they're using the same tools that, we're using to discover them to help, I guess, rediscover them. I don't know if that's the right term or not, while they're validating it. So they're like, yeah, just give me the POC, just give me the minimal write-up, and then we can move on because we don't have time to read your 20-page report.
Yeah, especially if it's 20 pages that are mostly invalid.
Yeah, I suppose in real time here, as I'm thinking this through, the argument could be, well, the LLM has time to read your 20-page report and create a summary, so maybe it's not that much overhead, but, here we go.
Yeah, true. Well, the summary there anyway, looking ahead, they said that they'll be reducing some reward amounts across Android and Chrome, and this will reduce the payout for a single bug report, but they will prioritize VRPs and total aggregate reports. So overall, they're basically saying we are going to keep paying more money for these bounties, but just bounties which can easily be automated with AI are not going to be as valuable. And it makes sense, right? I saw somebody the other day saying, like, the whole model of bug bounty is built on this, like, it takes this amount of time to find a bug, and then you get paid this amount for it. If it no longer takes that amount of time to find the bug, and there's way more people finding those bugs, then something's going to have to change with the bounty structure to make it. To make it
very
affordable,
basic
really,
supply and demand, right? Effectively is what you're describing. But I don't know. To me, like, and I could be reading Doug's opinion could be reading way into this more than not. But I think this announcement alone speaks volumes, right? One, Google has pioneered this industry from the beginning with Project Zero. I mean, they were the one that basically pioneered the 90-day disclosure thing and coordinated disclosure and all of that back in the day. And here they are again, I think, kind of setting the standard and setting the where we actually think AI is going to be useful and where it's not useful. I mean, you showed the first number there went up from 1 million to 1.5. We've got some people in media and around the industry panicked about losing their jobs or how AI is going to create all these vulnerabilities that are going to be completely overwhelming. And I'm not saying any of that's not going to happen. I just also think it's important to recognize the fact that Google raising their bug bounty in the current industry, current times, I think confirms for the rest of us that yes, AI is helping us, but it's not going to solve all the problems. It's not going to find all the vulnerabilities. Like, we're still going to need a human in the loop. And I just think that number raising speaks volumes to that. I also think the announcement, they didn't come out and say, oh, we're done paying for bug bounties because AI is going to find all the bugs. Right? That's not what they said. They said, no, we're going to keep paying for bug bounties because we want high quality vulnerabilities found by researchers leveraging AI. We're just tweaking the terms because we understand what the difference it makes in the industry. And then last but not least, and I'll get off my soapbox here, I think the last component is by continuing to do substantial payouts, and we can argue what substantial means, but these are high numbers, everything from the top of the line, even like the 200,000, like that's a good chunk of change, right? Every day.
I actually, just to interrupt you, I just remembered, it's funny because my friend Brootcat, who I met before, he posted like a month ago, or maybe even a couple of weeks ago, on Twitter, showing that he'd got 600k in the past couple of months just on Google's VRP. And I remember seeing that, and then like a few days later, or like a week later, seeing Google being like, "Okay, we're changing our bounty table," and I was like, "Ooh, damn you, Brootcat."
Yeah, should have spaced those out. Why are you doing submitting them all at once, right? Come on, now help the rest of us out there. I mean, every day I'm worried, Jonah, that I'm going to wake up and get a text message from you saying I'm a millionaire. I'm leaving because I submitted all these Google bug bounties. See ya, it was nice knowing you type thing. But no, I think the other what I was getting at before, I think the last component of this, which again, this is Doug's opinion. I'm reading into something that it does not say, right? But the fact that a company of Google's stature is willing to continue to pay out those volumes, I think also speaks to the understanding of where AI is being leveraged. It costs a lot of tokens, right? And as these models get more and more expensive and we get less and less subsidized by venture capitalists, a $250,000 payout for a bug that cost AI $100,000 to find, right, is not as big of a payout as it may sound when you think of your expenses. Now, yes, again, Doug's hypothesizing about the future here, and I'm not saying today it cost $100,000 to find a bug, but I do think we're headed in that direction. So I just think that this news kind of speaks to all of that anyway. All right.
Yeah, absolutely.
Well, I've already, completely messed up the AI swear jar, basically. So what else are we talking about today?
Oh, let me open this one first. This is the GitHub RCE. Did you see this one from Wiz?
I did. In fact, we had a decent amount of discussion internally at Rapid7 about this vulnerability, about whether or not to run it through our ETR program. So it's definitely an interesting one. I think, if no other reason, it hits GitHub, which is probably one of the largest, if not the largest code used by coders out there.
Yeah, it hit GitHub. I think one of the things from this, right, is like it hit GitHub, it hit the GitHub Enterprise server, but because GitHub worked with like the customers of the Enterprise server, and they obviously own GitHub, they were able to sort out that very quickly before I think this like got released to the public. But as you see here, the Wiz are indicating that 88% of locally hosted instances are still vulnerable. I think this was like locally hosted, like enterprise instances as far as I'm aware.
Is anybody surprised by that? That just sounds like the same story that we've been talking about for 20 years. Yeah, patching is slow. And I also think the nature of people that have internal GitHub servers also are more or more security focused. And wouldn't that mean they want to patch? No, they basically want to evaluate the patch and figure out how it's going to affect their system before they do it. I think is what you find a lot of times. So I'm not surprised about that number at all. But anyway, this was an interesting one. I don't want to keep interrupting you. Tell me about this bug.
Yeah, I'm not going to go into the deep dive here. It's interesting, right? Because this one is like a really simple payload, but like what's happening on the back end is more complicated. So the reason this kind of went undiscovered so long, with it being such a simple payload, and I'll show the payload in a minute, but the reason it went undiscovered is because this is all kind of happening inside binaries on the back end, and Wiz basically said, I think they said that they were able to do this in 48 hours, and it would have taken like weeks or months. I think they said, let me just double check that. Months of manual work, they said, I have in my notes. So if that's the case,
AI helping them do it in 48 hours?
AI is helping them do it. And it's different because they're looking at the binaries here. Like a lot of the AI bug hunting and vulnerability research has just gone into source code. So there's probably a lot of vulnerabilities sitting in these binaries, which are just like, not low hanging fruit, but now that you have AI, they could be. And it's basically about the chain here, right? So it's like, there's so many things going on as it's going through the different binaries that you kind of need AI to be, or you need months of time to be able to kind of piece it all together and make it work. And let me.
What's this payload you keep talking about?
Yeah. The thing is, they didn't actually just put the payload on the article, from what I can see. Let me share the LinkedIn. All right, so I saw this post on LinkedIn. We found a way to access millions of private repos on github.com with a single push command. And look at that.
Doesn't even describe what I'm seeing on the screen right now.
Yeah. you kind of wonder how nobody has accidentally discovered this over time. It's that simple that you'd think somebody just accidentally put this in and realized they've got RCE on GitHub, but apparently not.
That's incredible. That's about as simple as it gets from an execution perspective. But as you mentioned, not simple to understand and define.
Yeah, and think about the impacts. Like, I mean, they're talking about there, obviously they have RCE. If you have RCE on GitHub, they can start getting keys, they can start getting passwords, things like that. But you also have access to every repository that's on GitHub. So, I mean, like, could you just go and silently modify the most popular repos on there to distribute ransomware or crypto miners or whatever it is?
Blockchain attack, basically.
Yeah, I would imagine though, like GitHub have something. You'd like to think that you can't just like, if you get RC on the server, you can't just like modify every repo in existence undetected. You'd like to think there's some kind of mitigations or checks there to flag that. But
one would hope, anyway,
potentially.
But we have no insight one way or the other.
It's a potential for sure. I mean, they definitely had access to the private repos, because if you get RCE as Git, you're going to be Git on the server, right? So you're going to have like read and write access to all those servers, so, to all those repos.
Yeah, it makes you wonder in the conspiracy theory land, right? Like, if you want to think that way, has someone had access to GitHub servers and been, modifying packages that, everyone's downloading and including, and we're going to wake up one morning and the whole world's going to crumble because they hit, some special key combination to activate it? I mean, I watch way too many spy movies, but like, it's definitely a possibility. Right? You can't rule it out.
It's hard to even imagine, right? Like every repo on GitHub's just suddenly being malware.
Yeah, I think that what's crazy is it doesn't even have to be every repo. Can you imagine if just like, like one or two of the, I don't know, I'm drawing a blank off the top of my head, but like the most popular, I keep saying libraries, were modified that are, because it's a self-perpetuating thing. Like there's repos on GitHub that are going to use that library, that are then going to incorporate that library, right? I don't know whether it's one of the Google SDKs or one of the Facebook SDKs or something that would just like kind of propagate through a whole bunch of other apps for authentication or something. Like that would be a wild thing to wake up to one morning, but hypothetically it is possible. I'm not saying I to the conspiracy theory that this has happened. I'm just saying, like, when we find these bugs, you have to wonder, are we, especially when you see the payload being that simple, was it really the first time it's been discovered? I don't know. Anyway, okay, so no more conspiracy theories for now. I know there was more really interesting bugs that have come out, and really I think the one we've gotten a lot of questions about at Rapid 7, so I think it's a great one to hit that have come to my team too, is on this whole Copyfail situation. So tell us a little bit about Copyfail.
All right, so yeah, another vulnerability which was discovered by AI. So this is from, I can't remember the researchers who did this. I thought they had the company name here, but no. All right, well, yeah, it was another vulnerability discovered with AI, and it is a 732-byte Python script which roots every Linux distribution since 2017.
Well, I think like that one sentence is enough to riff off of for a while. I mean, hold on a second now. 732 byte. For those that don't recognize the fact, that is ridiculously small, right? 700 is, yes, it's a big number, but we're talking about bytes. We're not talking about kilobytes, megabytes, any other type of bytes. We're talking about straight bytes. So it's a super small payload that affects, what was it? Every single Linux distro since 2017?
Yep. Every Linux distro since 2017. So Ubuntu, Amazon Linux, Red Hat, yeah, everything. And so
here's a thought, right? Every single Linux distro in 2017. Now, for the most part, like Ubuntu, like this stuff's going to get patched. Yeah, I see Amazon Linux 2023. That stuff's going to get patched. SUSE is going to get patched. Red Hat is going to get patched, right? Who's patching every IoT device that's ever been created from 2017 forward?
Yeah.
Anybody raising their hand for that?
Yep.
Because or let's get Daryl back on here. Who's patching every single firmware on every single cellular device that's ever been created since 2017? That's the type of impact that we're talking about here. Like, that's nuts.
And for this one as well, I mean, I saw whenever this got released very quickly, this was released as like a Python script, but very quickly I just saw it gotten like put into every language and like, standalone binaries that could run this. And it's supposed to be like forensically silent as well. It's like one of the most undetectable local privilege escalations that have come out in a while. So
I think that has to do with, and I'm not qualified to dig into this, just to put my put everything out there, right? Like it has to do with the crypto, I believe, is the way that this is leveraged, and it's probably, I'm guessing that has a lot to do with why, from a forensics perspective, it's very hard to detect and to know that it's been leveraged. But I think some of the questions or thoughts around here that we've seen around Copyfail that are interesting to address is like, hey, is this important, right? And one of the reasons why I think the question's even been asked about, is this important for me as an organization to patch? And we can talk more about with Spencer on this in the mitigation minute. But some people think like LPEs are not, they don't always have the highest CVSS score. They're not always, they're not the RCE. Like, why is this getting so much attention? And yes, LPEs can be ridiculously detrimental to an organization. I think what we still see is that attackers don't always need a new entry point. Right? We still have humans that click the link. That's their entry point. What they need is how to move to the next step. And this is a reliable way to move to the next step across a massive amount of infrastructure that you're likely going to run into as a threat actor or pen tester. I mean, I think we will be running into this working for years, right? Because there's going to be a Linux box out there, or a Linux device, or a camera, or a printer, right? Or an X-ray machine, or, you name it, that doesn't have the patch for this, that's branched off of Linux. And I think that's really what the impact is from a Copyfail perspective.
Yeah, for sure. I mean, like, to go, if you get access to a system and you don't have root access, there's a lot less you can do, even just in terms of like getting over to like pivot into other systems and stuff as well. So super interesting topic. I did just check there. It was found by Zint Code, and yeah, their AI scanned the Linux crypto subsystem in under 1 hour to find a 9-year-old bug, which is indeed in the kernel crypto API AF_ALG. And yeah, I don't like crypto, so I didn't dig into the specifics of how it works.
You don't like crypto because you're normal, at least normal for
that's why I call myself Crypto Cat.
Yes. Yeah. Actually, that's make a whole lot of sense, man.
No.
All right. So besides Copyfail, anything else you want to talk about today before we move on to our awesome guest?
Let's just have a very, very quick look at this one. And I say quick because we've been going on for a while. We've got a really cool guest coming up and a nice demo at the end. So I don't want this to take us all day. And as usual, when Watchtower do a blog, they really do a blog. This was on the cPanel auth bypass.
We love your stuff.
Yeah, for sure. Crazy one. Here's a POC here. So you have POC with the domain and then just shell. Here you go. So there's the web panel running. Run a POC, and there you go. Root shell on the server. And pretty big exploit. I think they said there are somewhere north of 70 million domains with this running.
That's a couple, right? And so this is one that on our team here at Rapid7, we did run through what we call our ETR program, or emerging threat response, which means that we put out information to it, push to our customers, because we feel that this is widespread and really important to take a look at. And part of it has to do with too the way these systems are designed and set up to share other systems, that getting access to this type of infrastructure can actually allow an attacker to get access to other systems as well, right? Is that what I'm remembering about this cPanel portion, right?
Yeah, and there's a CRLF bug here which allows them to basically allows an attacker to basically inject into the cookie. There's quite a lot of other stuff going on here. I mean, let me just give a quick scroll here of the write-up, and you'll see why I'm not going to go through this all. But one interesting thing was as well, so the background of this attack, this was exploited in the wild before the vendor released a patch. I think it was exploited in the wild. It was reported as exploited in the wild from February. The patch came out in April, if I'm not mistaken. And yeah, Watchtower.
That's a long dwell time.
Yeah, and Watchtower, Synology from Watchtower basically diffed the patch and was able to go. There's actually comments in here. You can see the comments saying like, this kills the CRLF injection primitive. So quite a nice hint there for getting started. But yeah, they did a really awesome job basically going through this right in the POC. But I did see afterwards, Shubs from Asset Note basically posted and said they were also working on this. So, but it was like discovered in the wild. They had been looking at it, and I think they'd reached like the same level as Watchtower maybe with the POC, but they'd also found some other things in it, which some extra advice they could give for like defenders and for like running checks, because some of the checks, if I'm not mistaken, like some of them can like lock out the root user, so you can do like a slightly different different check, which doesn't risk the lockout. And yes, some other things. So if you're a defender looking at this, you can check out the Watchtower POC. Also check out the tool which was released by AssetNote or SLC Cyber. I don't know. I think they're kind of the same org, if I'm not mistaken. But they wrote a checker. And patch immediately.
Absolutely. And if you want one-stop shop to find all this information, we point to the Watchtower blog on the Rapid7 ETR blog. We point to the POCs. We point to that stuff. So always you can check it out there to kind of have your central point to find everything you need to know about this vulnerability. Well, Jonah, we have covered a lot. A lot has happened since the last time we recorded one of these things. Thanks for walking us through it. But I think that's going to be a wrap for the Situation Room. And we're going to move over to the War Room and talk to our guest for the week. What do you say?
Yeah, let's do it.
All right. See you there. All right, welcome to the War Room segment. This is our segment on the podcast where we bring in guests from all around the industry to talk about awesome research or things that they're doing. And we have a special guest, an extra special guest this time, if you ask me, because if you remember on the last episodes of Hacktics and Telemetry, we talked about in the Situation Room, we talked about a Roundcube zero-click exploit. And we talked about how APT28 was potentially or was being noted for leveraging that vulnerability. And then we talked about there's webmail servers that are still in-house, not everything's in the cloud, and we talked about a lot of these impact of these vulnerabilities. Well, we decided if we were going to talk about something like that, why don't we bring on one of the premier researchers that has found vulnerabilities in the same exact software? Jonah, what are we going to talk about here?
Yeah, all right. This was a cool one because I think it was like the day after we recorded that podcast, Doug. I just happened to open up LinkedIn and saw a link from Jorian, which was on a Roundcube XSS vulnerability. So I actually thought whenever I saw it, I was like, oh, this is probably the same vulnerability, but this is new. The old one had been exploited for a couple of years. So it's not, but I mean, it's the same target. It's the same type of vulnerability. So it'll be cool to dig into the technical details and see how it works.
So welcome to the podcast. We love to get our hands dirty here, and we understand that you're really good at looking at Roundcube. You spend a lot of time in it. So if you want, just start us at the very top for our maybe not as technical users, right? Walk us through what did you find in Roundcube? Maybe even a little bit about what is Roundcube,
yeah, so
right?
Roundcube, probably already mentioned, but kind of an email server. So it does all kinds of useful things for email servers, like the spam filtering, the actual viewing of emails, basically everything you would want. And it's actually a very interesting attack surface as well, because these email servers, they store very sensitive information, not only just in the contents of emails, but also just emails in general are very trusted. Like if you have access to some email.
Yeah, when you talk about sensitive information too, just to jump in here for a second, when we were talking about the other Roundcube vulnerability, one of the things that made it so serious is that it came out that a lot of European government agencies was leveraging Roundcube on-prem email servers, right? So that's kind of what, to your point about.
I think the article says this is the most widely deployed open source one, right? Yeah.
I think so. Yeah. Yeah. So go on. But I think that's great context about the sensitive information that's possibly on these email servers.
And things like password resets are also kind of trusting emails. That's a pretty high impact one. And so we took a look at this app using Aikido Attack. It's kind of the AI pen testing thing I'm working on. Work at Aikido Security.
Whoa! I forgot to tell you before we got started. Hold on, we got a thing here, man. We're trying not to talk about AI. Okay. Right? We're going to start putting a counter.
It's not possible.
In.
Don't worry.
Yeah, no, man. With this AI thing, man.
I have some questions about this as well. I was going to save it till afterwards, but I'll just ask now. So, I was interested about the discovery of this vulnerability. I don't really know too much about this Aikido, the automated pen testing thing. Is this completely automated? I know, how Expo is kind of just fully black box, just leave the agents running. Is it like that, or were you kind of semi-manually working with it and giving it feedback, or did it just give you a vulnerability and then you were able to go and start analyzing how it got to that conclusion?
Yeah, in this case, it fully found the XSS by itself, and then the exploitation phase, so going from just an alert to actually stealing emails, that's kind of the manual part.
Got you. Cool.
So hold up. I mean, if we're going to do this, we got to do this, right? So we were talking about, I think a couple of last episode before, Mythos and the impact on the industry and things like that. So if I heard you right, you still had to do something. You had to be a smart researcher in order to get this through. It wasn't just bam, AI did all the work,
right? Yeah, and
right?
I think that's going to stay for a bit for these client-side vulnerabilities, because it's quite a visual thing, a very human social engineering kind of thing. So an AI might not know all all of how humans work. So they don't know how to maybe trick humans, but that's where the
if they need a human hacker as well, I didn't really give much of an introduction to Jorian here, but I know him because whenever I worked at Integrity, he would make, right up to like most of the monthly challenges we did, he made some challenges himself, and also for our annual CTF, some like really, really cool stuff. Also like a lot of the client side stuff. And I think after that, you were doing some research for the Critical Thinking Bug Bounty podcast, is that right? Yeah, so I mean, if anybody's going to be helping the AI along to escalate the impact here, you know, I
love these client-side vulnerabilities in the browser, all these strange tricks, because browsers keep getting more complex and they keep making more vulnerabilities happen.
That's it. So do you want to, how do you want to do this? Do you want to share your screen and we'll go through some of the attack?
Details? I can go ahead and share the article.
It sounds like, Jonah, you're going to keep your job for a little bit longer. Apparently, I can't replace you with AI,
I hope so.
I think you're safe.
All right. So here's the article. I'll kind of walk through the first part quickly. So this is the part that the AI found so far. There's kind of two ways to render HTML in Roundcube. There's the most common for like actually rendering emails. That's pretty safe. But there's a second one while composing emails. So when you're writing your own thing. And that one was probably a lot less tested. So it had a pretty simple XSS vulnerability where you could upload an HTML file and it would just render the HTML without any content security policy, no sandboxing or anything to get XSS.
And that was specifically a different parameter you had to use, right?
I'm going to show it right now. So here I have a quick demo set up. Let me first log in.
Well, live demo. This isn't recorded, folks.
Pray to the demo gods.
Let's see.
Yeah, well,
Here we just have a simple Roundcube instance. And if I compose an email, I can attach a file here. And I made a quick file here containing just some hello world and like a script tag. And if we...
Oh yes, classic
XSS, maybe the simplest payload there is. And if we upload that and then kind of view it, you'll see the HTML here renders. The script tag doesn't execute yet. If you would check maybe like the console, you'd see that it is blocked by the CSP, which is kind of correct. But now the trick is that we can take this URL, which is kind of safe, and we can change this parameter action equals get to action equals display attachment, which is that different feature, which is probably less tested. Once we do that, you'll see that the XSS actually triggers. It kind of renders the HTML that we uploaded. And that's the basic XSS. So
very cool. Now at this stage,
well
if you were to submit this to a bug bounty program, you're probably going to get it rejected, right?
Right. The problem with this thing is that we did a lot of manual action here, and while it looks like we just have like a URL that serves an XSS payload, if you would actually send this to a different user, a different browser, they would actually get like an access denied page here. That's because this URL, specifically this kind of file parameter, this is kind of tied to your own session. You can actually see that here in the cookies. We have this Roundcube session, which is all the PHP session ID. And inside of that, it kind of puts a compose ID, which is the ID of that email you're composing. So the problem is you have to have this special session identifier to be able to access this URL. So nobody else will have that, of course. I thought a bit about like the biggest, or the first thing you might think of is trying to log into the attacker's account and then visiting this link, which is pretty common. We also did that with another email client recently.
If you do that though, what are you gonna? You're not gonna have access to their information,
that's a good question. We actually had that exact case a little bit ago. Maybe I can show it if you're curious. In MailCow, funnily enough, another mail client, where we had another self-XSS found by an AI agent that we kind of manually exploited to read emails, and that was exploited by a pretty cool trick. I think originally kind of popularized by Matamber, and the idea is that you can kind of open some sensitive information beforehand, Then we do the login step, the CSRF vulnerability, or whatever way you can log the victim in. And then using the XSS that you eventually have, you read the previous page that still contains the old information. So that's how you can kind of, in most cases, exploit that. And we looked at...
Cool. And why didn't that work
we looked at that in Roundcube as well. But unfortunately, this kind of compose ID is actually tied to the session itself. So if you log out and log back in, you actually lose this access. So we can't actually log into the... or we can actually log into the attacker's account, but we still wouldn't be able to exploit the XSS. So the last kind of step, the way we actually exploited this is using...
I just want to say, I love this. This is my favorite part of like finding vulns, right? It's the challenge of, okay, we've got something, but it's not like super useful in the state that we have. Like it's kind of contrived. Like how do we keep moving this to real life events? And I love the process that you're walking through here and showing us like how you get around some of these. I just think that's super valuable for people to see and understand. I think there's like a stigma sometimes from people that aren't, you know, in the bug bounty vuln research space about, oh, like, you know, you just sit down, find some vulnerability and bam, you got root, right? Like there's so much more that goes into it, and you run into all these different challenges, whether it's intentional mitigations or it's just ways the software doesn't work because you're trying to do something unintended. So I think it's cool for people to see us like walk through these challenges. But anyway, go ahead, continue with show us how you hack the rest of the
plan. Yeah, but I totally agree with what you said. Like it's very fun for me as well because I do a lot of capture the flag, CTF, and that's a lot of seeing the initial vulnerability pretty quickly. But the actual exploit is super hard and super complicated. You really have to like solve a puzzle in every vulnerability you find.
You mentioned CTF there, Jorian, and we were talking earlier about obviously the integrity CTFs. This write-up, actually, whenever I was reading through it, it reminded me, I don't know if you did this challenge, but Goatsniff, who used to work with me, he made a challenge, I think it was a Valentine's special challenge. I think it was 2024. So if you go back to like the February 2024, I think you still play it. But it was a cookie tossing vulnerability, and it was like so similar to this, you know. Yeah. So I mean, some people, you know, there's always a debate about how relevant CTFs are and is it like applicable in the real world. I think this is like a great example of, you know, a vulnerability that is.
I think I actually played
CTFs are such a great learning space, and this shows absolutely why.
Yeah, and so the trick to kind of solve this problem we have is to use cookie tossing. What's cookie tossing? We use a pretty obscure feature. I don't know if any application actually uses this, but there's the domain attribute on cookies. You might know that cookies have attributes, things like same site, things like HTTP only. These things you might check during a pen test. And there's one called domain. And surprisingly, it actually makes the cookie kind of less secure than the more secure, because with it you can scope them differently. Normally, of course, cookies only get sent to the origin which they're set on, but using this domain, you can actually kind of make it more broad on the entire domain. So also different subdomains and things like that. So to kind of show you.
I love features that help make things less secure. That's just...
And so the awesome thing is we can set this cookie that we kind of want on the victim's website. Or on the victim's browser, sorry. And we can set that using the domain attribute here to kind of scope it to a bigger section of the site. So you saw here we kind of want it on mail.target.local, but we actually set it on target.local. And so that means any subdomain will also get that cookie received, anything underneath it. And so what you actually need to exploit this kind of precondition is some other subdomain. Something like here, you can make like XSS.target.local. I'll do something that exists. And this is just imagine some site where you have an XSS vulnerability on, but it might be like a dumb static site, which is not useful. But you can use that as a kind of gadget to exploit Roundcube. So
this could be such a frustrating part of like if you find this vulnerability and then you can't find any subdomains that have an XSS on it, the whole thing's ruined.
Exactly, so you kind of have to wait for any XSS vulnerability to show up on a different site. So it's an interesting case as well. And I can kind of show how it works. So if you would go on this XSS subdomain and you would set a document.cookie like this for some name and value, and we set the domain to target.local. When I run that on the XSS subdomain, you can kind of see that it shows up there, of course. But if we go back to the mail subdomain, you'll see that it also shows up there with the kind of differently scoped domain here. So we've kind of tossed a cookie from the XSS subdomain over to the Roundcube subdomain. And that's a trick that's going to help us out here, because we can pretty simply just copy the attacker's cookies from the XSS to the XSS subdomain to the Roundcube instance, and that way you can have the compose ID matching with the session ID in Roundcube and actually access the vulnerable endpoint. Does that make sense so far?
So this part, so now you've gone from self-access, so you can now get access on the victim, but you still have the issue of retrieving something useful from them, right?
So let me kind of show how this works in practice. I kind of have a working session here because it's the attacker's session. And, oh, whoops, I just logged out. Log in again. Yeah, it's kind of a good proof of concept as well. Like if you relog in, of course, it doesn't work anymore. That's what I kind of explained earlier. And if you then prepare this payload again, let me grab the correct parameter again. There we are. So this is working for the attacker. And now we can kind of copy their cookies into this piece of JavaScript and execute it from the XSS subdomain. Let me show that as well. And from here, so we'll copy the session auth cookie like this. We'll also copy the session ID. And I actually won't do it in this browser. I have another browser here. I think it's better to showcase. So this browser clearly hasn't been logged into Roundcube at all. And now we're gonna kind of magically log it in. So let me reset the storage.
And just for our viewers' understanding, like what you're showing manually here could be scripted by an attacker, right? And you're just walking through the steps quickly manually. So like this doesn't have to be done in this way, but it's a good way to show what all the steps are.
Yeah, right now it's kind of a gotta allow pasting, of course. And grab this. So right now it's kind of the setup. This is what the attacker would prepare for the victim. In a second I'll show the actual execution of it. So copying the cookies again, and of course copying the URL. There we go. Okay, now we have kind of a setup going. So we have the XSS subdomain here, and we have separate to it the Roundcube subdomain. It has no cookies right now, but whenever we execute this JavaScript, it should set all the cookies, redirect to the vulnerable endpoint, and trigger the XSS. So you can see that this now has added the attacker's cookies to Roundcube, and that's why we can access it. So that's the cookie tossing exploit. But as CryptoCat already kind of said, there's a bit of a problem here because now we're of course logged into the attacker's account. And there's not really any loot in the attacker's account. Like, why would we do this? There's no emails to leak. So how do we actually access a victim's mailbox, for example? And then there comes kind of the last step, some more fun cookie attributes that we can abuse. Because there's a second one that's very useful. It's called path. And it's kind of, some websites use it, not many, but there are some use cases for it. But for hacking, it's a very good one to know because you can kind of scope cookies to very specific endpoints. And
I think it's really interesting to point out here, right? Like people ask all the time, like, how do I, get better at hacking? How do I find like these different avenues? And notice that what you're using here is you're actually using intended features
Absolutely.
built into the technology in which you're leveraging for hacking. So like you only see this if you have the understanding that there's these extra parameters that you can leverage and how they work, right? I say all the time that 75 to 80% of hacking is just understanding the software that you're working on. Like you can't spot these different ways to get around mitigations. You can't spot these different potential security weaknesses without having that knowledge. And I think I just wanted to highlight here that for a second, that you're using intended features in this technology to abuse them as the way that you're getting around issues that you're running in while you're hacking. And that's textbook, and that's awesome, right? And it goes to show how much you need to understand the technology you're working on to be a successful hacker.
Exactly, because the way I kind of found these things as well is just reading documentation that's publicly online. Things like Mozilla Web Docs.
The boring stuff,
that's
right?
a very useful site. So yeah, you can definitely find anything you need just by reading documentation as a hacker as well. Sometimes these applications also need kind of workarounds for different things. You can use these workarounds in your exploits to do certain things. Definitely a good tip. And so the path thing, what you can do with it is scope a cookie so it only gets sent when a specific path is requested. For example, if you set it to something like this, index.php/XSS, this is a path that actually still works on Roundcube because some PHP servers, they kind of accept anything after this index.php to still redirect to the main site. And the fun, yeah.
So this could have been another thing that could have stopped you, right? If you could have got the cookie tossing and then if you didn't find the right endpoint.
A weird thing about Roundcube is that every endpoint is on / actually. If you like browse this website, you will see that only the query parameters change. So you can't actually scope things to specific query parameters. You can only scope it to paths. So if it would actually only accept / as a path, we wouldn't be able to exploit it, which is what I'll explain in a second. But in this case, it did through this index.php kind of weird quirk where you can append any path and it will still accept that. So the final trick is to set the cookies that we inject to this specific path so that only when we visit that specific path, the attacker's cookies are used. And for any other path like / where we actually want to fetch useful stuff from, it'll still fall back to the victim's own session. So let me quickly showcase that as well. We have if I refresh here, I'll kind of clear the attacker's cookies here. Get back to like a reset state. So we have one cookie, let's say like the victim's cookie here, the EF session ID. And we'll do kind of the same exploit as I just did. Go back to the XSS subdomain. And we'll change the path parameter right here to each of these cookies. And we'll also change the path that we eventually redirect to that same thing so that these kind of match. And we use the attacker's cookies to request this final XSS URL. And once we do that, I hope the cookies are still valid. Yeah, there we go. We get the same XSS. But the crucial part now is that you'll see that these cookies that we set have a specific path, and the original cookies, like this EF one, is still set, still exists.
Yep.
And so once we now like do a fetch for / for example, you can see in the network tab that previously on this XSS response, we used both sessions. So we used both the victim session and the attacker session. Or other way around actually. And on this different path that we don't put attacker's cookies on, it actually fetches it without the attacker's cookies. So it uses the victim's cookies and we can fetch any mailbox things, send any emails that we want. We just have their account basically, like you have XSS.
So cool. It's just a masterpiece of an attack. There's so many small things that have to line up for it all to work. And what was the final impact of this then? You're able to exfiltrate emails?
Yeah, exactly. Like
any other stuff?
Use their authenticated cookies, of course, and in Roundcube that means you can, of course,
password reset.
Yeah, definitely. You can send emails.
Yeah.
phishing.
Okay. So it's a full
Yeah,
cat
you
takeover.
can request password
Awesome.
resets and things. Compromise any connected accounts. So definitely a high impact form.
And even,
Very nice.
I think what's interesting too is besides, I guess, the big ones like password reset, lock somebody out, change all that fun stuff. But I think the more interesting use case, especially if we look back to the APT28 example from the last Roundcube bug, is can I sit here and just passively listen or read your emails, right? And have anyone else know that I have access to your account? I think that staying quiet but still having access is one of the largest
That's
threats.
true. I
when
think it
comes to
said
something like this.
from 2024 to 2026, they had evidence of that going on from. So yeah, that's totally true. Like rather than resetting somebody's password and then the attack being over, you can keep going for years.
Yeah, and this is just another bug that allows someone to potentially be able to do that.
Yeah, and I think one kind of last thing I could mention is that, of course, we could read the current mailbox, but I haven't mentioned it in the final article, but now that I think about it, you probably can also read future emails that come in, as you said, by kind of installing some service worker or something like that, because this application allows uploads of files, as we've seen with the HTML one. So you could kind of get a persistent XSS on this Roundcube as well to really exploit it.
Perhaps mail forwarding as well. I don't know, depending how they set it up, you might want to do like a silent mail forward
in their IMAP thing. Yeah, definitely possible.
Very cool. Awesome. I noticed as well then, I'll just ask, this was reported via HackerOne.
That's right.
So this was another thing I was going to ask you about Aikido is, so what was the reason for choosing this target? Or was it like part of a pen test and then that was like on the pen test, so you dug into that? And also for disclosing to HackerOne, how does that work? Is it done as a vulnerability disclosure? Is it a bug bounty? Do you get a bounty? Is it split between the company? If you can disclose that.
Yeah, we kind of attempt to hack all kinds of mostly open source apps because they are white box tests. You most likely find more vulns, and that's what we're best at. Basically, at random, pick these big projects, things like Roundcube, that have like a big name attached to them. We run them through the AI pen test and kind of manually review the results, report anything that needs to be reported, escalate anything that might have potential to be escalated. Interesting thing about the HackerOne report on this case as well is that Roundcube is actually part of Nextcloud, and Nextcloud recently pulled out of HackerOne, kind of a recent thing in the news.
Because of the AI, right?
Following curl and maybe other programs.
Yeah.
So it kind of shows how you definitely need to also verify these things that AI finds. Because in this case, it was a valid XSS, but if you would have reported it maybe without the escalation to actually read other emails, they might have denied it or been like time wasted by this report.
Yeah, I think this has been a general trend. We saw it with curl. I noticed on Yes We Hacked that there was a FF, MPEG, and ImageMagick programs. I don't know if they come back, but they definitely disappeared for a little while, and I'm assuming it's the same thing. They're just like, getting overwhelmed by the amount of reports they're getting in, and probably a lot of them aren't in a great state.
Exactly.
It's interesting to see how workflows for this type of thing has evolved over time. Essentially, the concept's the same as like just picking an open source target, building a fuzzer for it, finding vulnerabilities, verifying that the fuzzer found something useful and then putting it forward. And now we've kind of augmented, or in some cases replaced, the fuzzing with leveraging AI to do that middle component of, find bugs and whatever, or find vulnerabilities. And now a human needs to review them and see what's possible with it and then can report it based on that. But it's the same age-old attack path, another tool in our tool belt as vulnerability researchers and bug bounty participants to leverage. So, hey, I think this is fantastic research. I'm so happy that we were able to get you to come on the show today and be able to show it to us. We actually have another segment after this that I'm going to jump the gun on a little bit because I won't have you to ask this question in that segment. But I think one of the things we try to do on this podcast is not only present problems, but we want to present solutions to those problems, right? So give me like 1 minute. Okay, great. We see the impact that this can have and this is important. But what are some of the mitigations that you found in the process or that you worked with Roundcube to implement to ensure that these things are not an issue moving forward?
Great question. The specific thing that Roundcube did to fix this, which is also what we recommended, is just to add a content security policy to this endpoint. It's the exact same solution that they use to protect the other endpoint. So it's a pretty simple solution. And that's definitely one thing I can recommend to kind of any application is use these security headers. How boring it sounds, however boring it sounds, they really do help. Things like content security policy can make an attacker's life miserable, and that's what you want as a defender, of course. Definitely try and set those as strict as possible with nonces, with things like the self domain. Try and really ensure that there's no way to execute malicious JavaScript.
Yeah, no, I think that's a huge call, and I love that you call it like this boring advice that that we talk about, because I feel a lot of the solutions is the boring stuff that we've been talking about for a decade. And I made the comment earlier about you as an attacker leveraging the technology in order to abuse the technology. Well, I think the same thing goes in reverse, right? Like as developers and defenders, we need to understand what was built in for protections that we can put in there or leverage properly, or is going to make the attack surface that much harder. And as you see, as you walk through these three different main portions, I'm going to call it, of hurdles that you have to jump over, like a lot of things have to line up to make this work. So anything that a defender can do to just slightly make that more difficult sometimes moves the needle from plausible to not plausible. And so like in your example here, using those headers that are designed to make things more secure takes something out of play that is very easy. I don't want to say easy, but it's the path exists because those headers haven't been used, right? Exactly. So I think that's a great call out. Well, hey, Jorian, I want to thank you once again for showing us your research here. I'd love to have you back some other time. If you've ever got some other big, cool research that you want to show, make sure you hit us up. We'd be happy to have you back. But we're going to wrap up the War Room segment here. And before we do that, anything like social media or places that people can reach out to you, or blogs that you publish that you want the audience to know about?
Like if you want to learn more about these very obscure, very deep client-side vulnerabilities, I have a blog, jorianvulture.com, where you can read all these write-ups of CTFs, real-world situations that I try and exploit. And of course, Aikido.
Awesome blog. We'll leave that linked as well in the
absolutely. We'll put that in the show notes.
And of course, on Aikido, I work on the publishing of blog posts now, so you'll probably find a few more fun 0 days soon.
Yeah, give us a shout if there's any more you want to talk about.
Yeah, well, and I'll definitely keep an eye on it myself. And if our viewers you want to check it out, check out the link in the show notes to the great work that Jorian's been doing. We're happy to have you here. And till next time.
Thanks very much, Jorian.
All right, welcome to the Mitigation Minute. If you're not familiar with our podcast structure, we specifically have the Mitigation Minute to try to talk about, hey, there's all this crazy chaos going on in the industry, and we just talked about it. We had some guests show us some different exploits. Like, what can we take a minute to focus on about a mitigation perspective of how to prepare yourself for some of these vulnerabilities? And if you watched episode 1, we had the one and only Spencer join us, and he gave us some really cool Metasploit demos. Well, we've brought him back because I think in the world of LPEs and AI, he's got some cool stuff to show you on Metasploit to do just that. But before we get to that, I want to make sure we don't just only talk about AI and Mitigation Minute, right? We talked about some other things throughout the episode. So we talked about things like the GitHub vulnerability, right? As long as you're using the hosted online cloud hosted GitHub, you got lucky on that one, right? GitHub takes care of that patch, and there's not a whole lot you got to do from an organizational perspective. But we also saw that Jonah showed us that the statistic currently was that 88% of current on-prem GitHub enterprise instances were not patched, right? And so I think this is just one that we showed you how simplistic that POC is. We want to make sure that you actually go ahead and patch that one. And really the same thing when it comes to cPanel is to ensure, like, I know it's not super cool advice here, but that's still the number one way that you're going to take care of those vulnerabilities. Really want to spend the majority of the time in this segment, though, talking about Copyfail and talking about some of the new AI stuff that we were talking about in earlier segments, right? And so that's why we brought Spencer in. So Spencer, welcome to the Mitigation Minute again. We are so happy to have you back. And the first thing I want to do to kind of jump into the conversation here is take this one step back and say, when we're talking about the context of Copyfail, really what this is what we refer to as an LPE in the industry. If you're not familiar with that syntax for my listeners here, that means local privilege escalation. And we got a lot of customer questions here at Rapid7 talking about, hey, this isn't some big RCE bug. This isn't the CVSS 10.0 type of bug that we see. how does this matter to me? And what I think is interesting to get your context on here, Spencer, or your thought is you run our entire Metasploit program, right? And Metasploit, I've been a long-time user of Metasploit, huge fanboy, right? Has a huge library of LPEs. So if these are lower CVSS scores and not as much higher priority, just walk me through for a minute, like, why do we even have such a large library of LPEs in Metasploit, and what does this mean from a Copyfail perspective?
Yeah, absolutely. So our LPEs are all kind of geared towards working off of a session that like we already have in Metasploit, like your interpreter session or your shell session. And what's really important of how the LPEs kind of fit into, like the penetration testing, the security assessment methodology is that a lot of times you get an initial foothold onto a target system. Phishing is still extremely popular. A lot of companies and organizations are getting breached via phishing. And when that happens, the attacker doesn't typically gain administrative access because nobody's running as local admin, right? I hope. But even, outside of that context, a lot of remote edge devices have vulnerabilities in them in like the web application. The web application is not running as root. So when the attacker exploits that, they gain a foothold as like a service account that they can do some things with. They have access to the application and like the database credentials and those types of things. And a lot of times the attacker can pivot from that perspective. But if they want full system compromise, then they need a way to get to root or NT authority system. And that's where the local privilege escalation vulnerabilities kind of step in there.
I think you said, hold on, I'll stop you for a second. I think you said a couple things that are really key for our listeners there, right? Like one is you mentioned the word pivot, right? And so if you're going through as a CISO or any type of leadership and you're reading all of the threat reports that come out, you hear a lot of this concept of lateral movement. Right. And lateral movement is what Spencer's referring to there when he talks about pivot. And one of the things that they're pivoting for is to find a way to get that root or NT system access, which is then given to you by these LPE exploits. Right. So I think that's really important. The other thing that you highlighted in the beginning was, hey, we still have phishing as one of the number one breaches, or like, hey, take a look at some of our dark web data. We're talking about buying passwords. Right. We're talking about getting initial access. Unfortunately, in 2026, the reality is threat actors are not finding that hard. Right. So then what they're moving on to is leveraging these LPE type exploits. And I think that's one of why it's so important from a pen tester perspective, because it's supposed to be defensive segment. Right. Well, hold a minute. Why are we talking about exploits in a defensive segment? Well, we're talking about exploits because the way you defend your organization is to do validation on whether or not you have these issues in place. And one of the ways to do that is by leveraging tools like Metasploit and Metasploit Pro to be able to do that validation to know whether or not an attacker can get that foothold. Sorry, I didn't mean to completely jump off the train there, Spencer, but I just want to highlight that for our listeners.
No, like that's really good context. So yeah, the pivoting is like a huge angle. But the other thing that we haven't talked about is kind of like, why would an attacker want to get root or NT authority system? I know plenty of pen testers that are highly effective and they never like escalate privileges, but there's a difference between a professional pen tester who goes home at night and a legitimate threat actor that needs to establish persistence. And in a lot of cases, attackers are going to have a lot more options available to them to persist and maintain that access and siphon off that data if they've elevated to like root or system.
Yeah. And so in the age of AI, when we're talking about, leveraging AI to help both pen testers and vulnerability researchers, that counter keeps going up and up, I'm sure, of our AI, our tings here. And CryptoCat's drinking. Is this a drinking game that we're doing now? Every time we say AI, did I miss the memo?
Yeah, that's it.
And anyway, I digress. So as Metasploit evolves, what are we evolving in Metasploit to help when it comes from an AI perspective that we can also talk about around these LPE exploits?
Yeah, absolutely. So the Metasploit team is internally using AI to kind of, quicken development. But what our users really probably care about is that we are trying to enable them to better leverage AI to provide guidance in terms of how they are using Metasploit. One of the consistent pieces of feedback that we've heard for a really long time is Metasploit's a little difficult to use. There's a lot of nuance to it. There's a lot of options. When you successfully compromise a host, if you're not intimately familiar with all the LPEs or all the pivoting methodology, you may not necessarily know like, what can I do next? So one of the things that
Metasploit's supposed to be easier to use than VI. I just thought they basically were supposed to be the same technology.
Right, absolutely. We also won't let you exit. You have to get a session first before that's the trick.
Keep that session open. Don't close that session.
Exactly. Yeah, for sure. But so we have introduced a MCP server that I'm actually really excited about. Just came out last week. It's our very first rendition, and it provides a read context into the Metasploit framework, so you can get all of your modules and stuff like that. But even better is it can get read access into your database. So if you're running Metasploit with a database, and it will help you keep track of all those hosts that you've identified, the vulnerabilities, and the credentials, and it will help provide like guidance and try to tell you, like what you can do next if you kind of ask it.
Hey, Spencer, I've been in the hacker community for quite some time. I know you have too as well. And there's a hacker kind of methodology I'm sure you're familiar with. Have you ever seen the POC or GTFO concepts?
100%.
Right? Okay, so I'm going to throw that to you right now. Stop talking to me about an MCP server and show me what you got.
Yeah, absolutely. Okay, so this is a standard MCP server that we've got. We just dropped it last week. The release, I believe, is 6.4.131, I believe. So by the time this airs, we should be all set. And so I am going to share my setup. So here in the top window, I am running inside Metasploit Framework. And I just kicked off the MCP server, MSF MCPD, and I'm telling it I want to communicate with it over HTTP. And then down here, I have Claude Code. That's my preferred one. I know other folks have used Cursor and other MCP clients, but I have Claude down here. And one of the first things that I did was I kind of asked it, like, what have I checked on my network already? And so it's telling me the various services and the vulnerabilities that I've already identified. So now last week I was actually looking into Copyfail. So you can see that it had already flagged that here. But if I wanted to say, hey, I have a session.
I like how you talk to it like a person. You have the hey in there and everything. Like,
oh, for sure.
Is that how you're supposed to talk to AI? I don't talk to AI that way. I'm more abusive. I just tell it what to do. I don't try to be nice to my AI.
I'm always trying to be nice to the AI. I don't know when the script is going to get flipped here.
Yeah, I know. I suppose that's fair. I suppose I should be probably less of a dictator to my AI. Because it is always nice back to me. Like, have you ever got it where one of the LLMs will be like, oh, you're on the right track, or they'll be like, this, you have the right process, or something like that. They're always like kind of building you up.
I got a little sass last week where it was like, I don't know if you were hoping I wouldn't notice this or not, and then like continued on. I'm just trying to get this thing done. Too. Let's see. Okay, so I had mentioned to it that I am on a Linux host and I'm not root. So I was hoping it would kind of tell me like where to go. This is actually an interesting perspective. So it's telling me that I should use the local exploit suggester. Wasn't quite the answer that I was hoping for. I was hoping to be like, oh, like you have Copyfail instances in this target environment. Go ahead and use Copyfail. But it's actually telling me that the standard playbook is that you need to use the local exploit suggester, which itself will actually go ahead and run.
It didn't necessarily give you the answer you wanted, but that's not a bad answer.
No,
right?
No, I mean, like, that's not wrong. That's good, solid answer here.
And to your point, right, if you're not familiar with Metasploit and you're not familiar, maybe you're also new to pen testing, right? And you don't know what the classic methodology is, that is 100% a great move for you to do. And does it, I'm trying to see the screen here, does it give you the path? Yeah, it gives you the commands too, right? It says use, post, multi. I'll tell you what, I've been using Metasploit for over a decade and I still don't remember what all those paths are, right? Like I'm always looking around trying to find the right module, but maybe that's just my shortcoming. But anyway, like the point that it shows it to you there, I think is pretty cool.
Yeah, so absolutely.
Spencer, sorry, I was going to say, is this only like read only? It's interacting with the database to see like, oh, these are the hosts and this is what's been checked before, but it doesn't control Metasploit from there, or is that an option as well?
That is going to be the next option, yes. In talking to a lot of our users are understandably maybe apprehensive about having like a AI auto-pwn option. So we are going to enable it, but it's going to be an optional component. We haven't decided on opt-in versus opt-out.
Is someone concerned about maybe Claude deleting their database in 9 seconds?
That's what I was thinking.
You're getting at?
I mean, we're not using Railway or Claude. It's like the whole full stack. But yeah, we're a little bit concerned about that. People are understandably a little bit apprehensive. But yeah, so we're going to enable users to be able to have all of like the writing capabilities, because like eventually we would like them to be able to be like, go find me a vulnerability, find me a way to be able to run this up. One of the things I'm particularly interested in that we need to do a little bit more research in is I want to know if I can have it help me when an exploit fails. Ideally, I want to be able to deliver something to our users that like exploits always fail in the, not always, but like it's oftentimes that things don't go according to plan. And we're really hoping to have an MCP server be able to provide some context and be like, this data store option was set incorrectly, or like to provide some guidance. And we kind of already have that to a degree from more of a workflow perspective, where the module can see like, or excuse me, the MCP server can like see like what you've done and help provide some guidance. But down to like a specific like run instance would be really helpful next.
Are you familiar with the term bit rot?
Yes.
So it was one of the things that I teach in the exploitation class for SANS. By the way, I'm teaching in San Diego next week if anybody wants to join me. But one of the things we talk about is bit rot and having to be able to modify. In fact, we go through exercises taking Metasploit modules and modifying them because of the fact that time has changed. They don't work the way they used to. How do I upgrade that? So I bring that up because I think it'd be interesting. Do you foresee in future releases, now to be clear to listeners, this isn't current, right? As he said, there's no write capability in I believe that's what you're telling us, right? There's no write capability in the current release. But in future, when there is write capability, do you see a world where the MCP server can actually modify Metasploit modules for things like bit rot?
That might be like a kind of like a third tier type of thing. But yeah, that'd be really interesting to be able to have it go in and like fix the module for you. As I mentioned, on the Metasploit team, we're kind of using AI to like kind of speed up our workflow. And I've been able to provide like Claude Code with like a resource file, say this exploit, actually it was Copyfail. Copyfail wasn't working on the ARM LE last Thursday, right before the release. And I was able to give it this test case, and it went in and helped me identify the actual issues within the payload was the problem, and then iterated on it until the session started working. It was amazing. So being able to integrate it into that perspective would be fantastic and help a lot of our users. When I was doing pen testing, we saw quite a bit of that, in particular for HTTP stacks, where you would have to have like different like headers that the module wasn't necessarily using because like the deployment required authorization in like a certain format type of thing. So that could be incredibly helpful.
Absolutely. Well, and that was I don't know if you did that intentionally or not, but that was a fantastic segue. So you were saying that you were using it to help you with Copyfail. Because that's such a prolific exploit, we know that there's now a Metasploit module that has been built into it. Can you walk us through that Metasploit module, show us how it works? Because this is, Jonah and I mentioned in previous segments here, it works on every single Linux distro from 2017, if I'm not mistaken.
That's right. And I know we were talking about like the importance of LPEs a little while ago, but to frame it for why this one in particular is so important, traditionally, a lot of LPEs on both like Linux and Windows, a lot, not all, but a lot rely on like kernel or like driver mode memory corruption historically, and that can be very, very fragile. And in the context of an LPE, when you're attacking the kernel, when something goes wrong, it goes really wrong. The entire system will blue screen, will die, reset, all services, connections drop. It's not a good time.
Yeah, and the attacker or the pen tester wants to stay as stealthy as possible, right?
Yes.
So that risk of messing up in the kernel is pretty high. In fact, to the point where sometimes a threat actor will choose not to use something they know might work because they don't want the risk of throwing like a red flag that I'm here. So
100%. I've gotten a lot of feedback from like pen testers and stuff that like, they won't use like all the LPEs and like particularly like kernel mode stuff because of that risk. They don't want to, understandably, they don't want to harm the client. Copyfail, however, is extremely reliable and has been extremely reliable in our testing. It's not a traditional memory corruption bug. It's a logic flaw. And so I have run the exploit as part of, doing all of our different target testing that we do as part of Metasploit process, and we haven't had any notable system instability. There's an artifact where if the exploit doesn't complete, it may not clean up after itself, and so like the subinary might not be right, but we do put that back in Metasploit. But overall, it's leaps and bounds more reliable and less likely to cause those types of crashes than some other vulnerabilities. Combined with the sheer breadth of available targets and the lack of prerequisites makes it an extremely valuable LPE. Probably one of the most valuable LPEs that we've seen since like sudo baron same edit in the past.
Yeah, that's saying something. I'm going to say it to you again. POC or GTFO, Spencer. Come on, let's go. Let's
all right.
show
Let's go here. So this very bottom one, actually, it did end up calling out Copyfail from within my environment, and so this is the workflow that we're going to use. This vulnerability doesn't require knowing a whole lot of information, so there's not a whole lot to go through the setup, but let's take a look. So
What
over
I was
here,
reading on this, Spencer, as well, this doesn't touch the disk, right? It's just in memory, so there's like there's very little like artifacts, a way of like detecting this after the fact.
That's correct. Yeah. What we do is we have a collection of 3 Python scripts that are invoked entirely in memory. The first one performs a pre-flight check to make sure that the target appears to be vulnerable, followed by the exploit, followed by that third one that cleans up that artifact that I had mentioned to restore the SU binary back to its original state to clean things up for our users. So in this case, I am on a Ubuntu system. So this would be like, I had gained access as the S McIntyre onto this target, and I am not running as root. So it's a 24.04 target. So the most recent LTS, I guess that's not true. I think Ubuntu 26 came out just like a week or 2 ago. But we're going to go ahead and use our exploit module. I am going to use session -1, which is a shortcut for the most recent session for any of our users that aren't familiar with Metasploit.
I just learned something.
Yeah,
I've been
I never
using
do that.
Metasploit forever. I didn't know you could do a -1.
Yep, absolutely. Yeah, -1 is going to be the most recent session. I like
Look
to
at
call
that.
that out because a lot of folks miss that sometimes. And so our default target would use one of our fetch payloads and write to disk. But Jonah, you had mentioned wanting it to be entirely in memory. So let's change our payload to run something entirely in memory. Because the exploit already requires Python, we can go ahead and have it run a Python stager and keep everything off of disk.
That's the hotness right there.
That is right. And quite a few fewer target or options. And I want it to connect back to me on that port, and I'm going to set the L port to a different one so it's not conflicting with the original. It shouldn't matter, but we'll try to get that cleaned up anyways. So before we can go ahead and check the exploits, it's going to run that first of those 3 Python scripts. And it can set up the socket, make sure all the primitives are available. If you're on a hardened Linux system that filters and doesn't expose some of the AF algorithm kernel namespace into the user mode, this would catch that and say, like, the exploit's not going to work anyways before anything really takes place. Likewise, I think I've heard that, like, some targets like Android OS doesn't support this. So hypothetically, if you could get a interpreter on Android, this would catch that the exploit's not going to work. But with that out of the way, we can go ahead and run it.
The suspense is killing me.
Right? Yeah, we are doing it live here. Okay. And so we had a hiccup here. Let's go ahead and checking my target. No, that is definitely me.
This is great though. Like, I talk about at conferences all the time. Sometimes I like demos to fail on the first try, right? It's because that's realistic, right? And then what do we do to walk through and figure out how to debug this problem? And there's nobody better qualified than Spencer to figure out what's going on with a Metasploit module. So it's definitely good to see the thought process here.
We're gonna switch it up from the payload. Actually, like, I'm wondering if there's something going on with the Python invocation that I might need to check out.
All right, let's do that. So here we're switching back to the interpreter payload.
Yeah, we're going to switch back to the interpreter payload. All of our other options are all the same, so let's go ahead and give this a shot here now. There we go.
Okay. There's the staging. There we go.
Cool.
So we did have to write to disk. That Python payload should have worked. I will have to double check that. But here we are. So now we are running as root. And we're on our same target. And then I always like to do a PWD, just kind of like my general showing, because that's like the context of like where the exploit was run from. And so in this case, it's the same directory that the previous session was using.
Yeah, and so just to be clear though, because we had that little snafu there, right? Like the exploit Copyfail itself didn't require writing anything to disk.
That's
correct.
It's
just the payload afterwards, right? So it's still, that's why the copy, one of the reasons, one is it's a logic bug, 2, it doesn't write anything to disk, makes it very hard from a forensics perspective to detect that the exploit was leveraged, is the way I understand it. Is that correct, Spencer?
That's absolutely correct. It's a little bit confusing because it overwrites the SU binary, but it overwrites the SU binary in the kernel's page cache. So not in disk, it's that memory cache of the data that was loaded from disk to speed things up that the kernel uses. So it's not actually overwriting it on disk. If the system were to reboot, everything would reset nice and clean. Nothing is like stored persistently.
I don't think it gets me more excited than a beautiful exploit like that. That's just fantastic from a hacker's perspective.
And that's definitely why this one is so noteworthy, being reliable, clean, not requiring anything on disk, able to be cleaned up, not needing any additional settings, any additional knowledge. It's particularly impactful.
Now, I'm going to put you on the spot here for Spencer, and if you don't want to answer this question, that's totally fine. I'll definitely give my perspective on it because I know we didn't talk about this ahead of time, but I do think it's pretty interesting. I'd love to get your perspective if you're willing to share it. And that is, there's definitely some people out there that would look at Rapid7 and look at Metasploit and say, hey, if you're telling me this is such a serious exploit, like why are we as Rapid7 willing to release a publicly available Metasploit module that's only going to make this easier for the industry to use, right? Sometimes we get that feedback from the industry. I would, as someone that's been doing this for a long time and is integral into the Metasploit framework, I'd love to hear your perspective on the value that Rapid7 provides by giving this to the industry.
I'm very biased, of course, but of the most important things about Metasploit is the testing that we put into it. As I mentioned, I didn't work on this alone. This was a combination of a lot of research that I was finding online from researchers external to Rapid7, but even additional folks, at least 2 other people inside Rapid7 helped me test this on a variety of systems. I think we tested it across multiple architectures, multiple Linux distributions, and things like that. And like I said, we noted that there was never any real system instability, so that we know that the exploit is cleaning up after itself. Furthermore, the original POC, if you've looked at it, I know they were very excited that it was like less than like 800 bytes. It was like 743,
I think, or something like that.
Yeah, and some change or something. Inside there is a very large binary opaque blob. I hope everyone that was pulling that down from the internet and running it on their systems kind of validated what that was. That is an ELF executable. That ELF executable means that the public POC is tied to a very particular architecture. And so what we were able to do in Metasploit is also transparently identify what the target is. So in this case, this is a 64-bit Ubuntu target that we have, and we're running command payloads, but our exploit does also work on AR64, and in the next version is going to work on ARM LE. So we're expanding those targets out in cases where like the original public exploit wasn't going to be able to work. And so that may lure users into a false sense of security. And like, it is noteworthy that you're defended against the public exploit, but there's a nuance there that doesn't mean you're not affected by the vulnerability. And so that's another area where like Metasploit is kind of able to step up with like the expanded target support and that reliability and the fact that we have vetted it and tested it before distributing it to our users.
Well, I think that's great. And if I could just highlight some of the underlying themes that you're saying in that, right, is that someone is going to have content related to these vulnerabilities, right? Mm-hmm. It can either be the threat actors only, or it can be the threat actors and the defenders. And the value for the defenders is to being able to confirm whether or not they're actually vulnerable to this. You want to test it before a threat actor tests it against you, because you guarantee that's going to happen. And then if you take that to the next step, what Spencer is saying, that we don't want to trust just random POCs that are thrown up on the internet. I teach this in SANS as well, right? You should always be testing your shellcode before you run it, right? And absolutely. If you are blindly downloading POCs, we could probably do numerous cases of how many bad or malicious POCs have been posted to the internet. You really want a trusted source to do that validation. Metasploit Rapid7 gives you that trusted source to do that validation, because as Spencer said, it wasn't one guy in a closet taking a look at this to make sure it works. There's an entire team, and sometimes an entire community with the Metasploit open source community validating that these are safe. Seems like an overstep of the word safe, but they are legitimate POCs that will tell you whether or not you are vulnerable to it. And there's nothing better than knowing whether you are protected or not against some of these most notable exploits in the world. We have to equip defenders to do that. And Spencer is just one of the many ways that Spencer and his team are one of the many ways that Rapid7 is providing content to defenders, not threat actors, to be able to validate this and be protected against these threats. Hey, I just want to, we've gone long here, but I think it's been a great segment. So I'm super excited to push this out. Spencer, thanks again for spending so much time on the Metasploit modules, for coming back on the show, to showing us how the MCP server is going to take Metasploit to the next level, and how easy that it will be for the Metasploit community, pen testers, organizations to validate whether or not Copyfail is in their organization.
Absolutely. Yeah. Thank you for having me.
All right. With that, we are going to go ahead and wrap up episode 5 of Hacktics and Telemetry. Please, if you liked this episode, subscribe, subscribe, share it on YouTube. Also, big announcement. I meant to mention this in the beginning, but we are also now on Spotify. So, of course, you don't get the visuals for seeing it on Spotify, but you can listen to this in your car as you're out going for a jog. That's the way I like to listen to my podcast, but we have expanded platforms, and stay tuned. There are more to come. So thanks so much for checking this out, and we will see you next time.